In this video, let me consider one numerical on node analysis. Find I0 in the circuit using node analysis. This is the given circuit. We are supposed to calculate I0 using node analysis. So here we can see that this is a node and this is a node, and let me consider this as reference node. Let me assume voltage at this node is V1 and voltage at this node is V2. This is reference node whose voltage is 0. I'll assume current through this branch is I1, current through this branch is say I2, and current through this branch is say I3. So as we know, in node analysis we are supposed to apply KCL to each node, and node voltages are the variables. Let me apply KCL to node V1. Apply KCL to node V1, that is incoming current is equal to outgoing current. Here I1 is equal to I2 plus I0. So in node analysis we are supposed to express this current in terms of node voltages or in terms of voltages. So I1 is equal to 20 minus V1 divided by 10. 20 minus V1 divided by 10 is equal to I2 is nothing but V1 divided by J5 plus I0 is nothing but V1 minus V2 divided by minus J4. V1 minus V2 divided by minus J4. So let me simplify this. That is 20 by 10 is equal to, I'll send minus V1 by 10 on RHS, so it will be plus V1 by 10, V1 by 10 plus V1 by J5 plus V1 minus V2 divided by J4 minus J4. So let me continue here. So I can write 2 is equal to 20 by 10 is 2 is equal to V1, we have 1 over 10 plus 1 over J5, so it will be minus V1 by J4, or I can write plus V1 by minus J4 as it is, and here we have minus V2 1 upon minus J4, not V1, this is just V1, 1 upon. So let me simplify this. 2 is equal to V1. So simplifying this, we will get 0.1 plus 0.05 J. Just substitute these values directly in calculator, keeping calculator in complex mode. And here we have minus V2 J 0.25. Let me call it as equation 1. So now similarly apply KCL to node V2, that is apply KCL to node V2. So here we can see I2 plus 4 is equal to I3. I0 is entering node V2, 4 amp current is also entering node V2, and I3 is leaving. So we can write I0 plus 4 is equal to I3. I0 plus 4 is equal to I3. So I0 is nothing but V1 minus V2 divided by minus J4 plus 4 is equal to V2 by 4. So therefore we can write 4 is equal to V1. I'll take this V1 by minus J4 on other side. It will become V1 by J4. This will become plus, and I'll send this V2 on other side. It will be minus. This minus and minus will get cancelled. On taking on right hand side, it will become V2 by J4, and here we have V2 by 4, or I can write 4 is equal to V1 1 over J4 minus, or I can write plus V2 1 upon minus J4 plus 1 over 4. So simplifying this, I'll get 4 is equal to minus j, 1 upon j is minus j, 1 by 4 is 0.25 V1 plus here it is V2. We have 1 upon minus j is plus j, 0.25 plus 0.25. I can rewrite it as 4 is equal to, we have minus j 0.25 V1 plus 0.25 plus j 0.25 V2. Let me call it as equation 2. Now we are supposed to solve equation 1 and 2 using Cramer's rule. So now solving equation 1 and 2 using Cramer's rule. So in Cramer's rule, first we are supposed to represent these two equations in matrix form. So that is, we have 2 and 4 is equal to, that is, in first equation we have on LHS 2, and in second equation we have 4, that we are supposed to write it as 2, 4. Now write the coefficient of V1 and V2, that is 0.1, 0.05. Coefficient of V1 of first equation is 0.1 plus j 0.05. Coefficient of V2 in first equation is j 0.2 minus j 0.25. Then here the coefficient of V1 is minus j 0.25, and we have coefficient of V2 is 0.25 plus j 0.25. 0.25 plus j 0.25, we have V1, V2. So to find V1, V2, first we are supposed to find the determinant of this square matrix. So let me find that, we will call it as delta. Delta is nothing but determinant of this matrix. That is, determinant of this will be this term into this minus this into this. That is 0.1 plus j 0.05 into, we have 0.25 plus j 0.25 minus multiplication between these two factors, that is minus 0.25j square, because this into this is square. So solving this, so directly feed these values in calculator, we will get is equal to 0.075 plus j 0.0375. So this is delta value. Now let me calculate V1. So to calculate V1 will be equal to, so in this matrix replace, as we know, these are the, this column is coefficient of V1, this column is coefficient of V2. To calculate V1, we have to replace this column with these two values, that is 2, 4, and keep these values as it is, minus j 0.25, and here we have 0.25 plus j 0.25. We have to find determinant of this, divided by, we have to use delta. That is, the determinant of this gives 0.5 plus j 1.5, and we have divided by delta. So solving this, we'll get V1 is equal to 13.33 plus j 13.33 volts. So now similarly calculate V2. So V2 is equal to, so now keep V1 column as it is, that is 0.1 j 0.1 plus j 0.05. Here we have minus j 0.25. So here V2 column should be replaced by these two values, that is 2, 4. Find determinant of this divided by delta. That is, determinant of this will be 0.4 plus J 0.7 divided by delta. So solving this will get V2 equal to 8 plus 5.33 J. So this is V2 value. So now here we know that I0 is equal to V1 minus V2 divided by minus J4. Let me calculate I0. So therefore we can write I0 is equal to V1 minus V2 divided by minus J4. That is V1 is 13.33 plus J 13.33 minus we have V2, that is 8 plus 5.33 J whole divided by we have minus J4. Therefore simplifying this we'll get I0 is equal to, so we'll get minus 2 plus J 1.33. Keeping this in polar form, we can write it as 2.40 at an angle of 146.3 amps. So this is the value of I0. Thank you for watching.